All right, let's do something similar to this. Let's go on to example 6, which is going to be number 19 in the book. So if you will pause the video for a second and just look at number 19, just get some thoughts together, maybe write down what you think the variables should represent, and then let's come back and work on the problem together. Okay, well if we look at this problem, it's basically just talking about groups of people riding a bus. And we know for a fact, I go to that very, very last sentence to help me declare what my variables are going to be. That last sentence says, how many children and how many adults rode the bus during this morning shift? So let's just say X is the number of children and Y is the number of adults. All right? And like before, we've got two variables. We need two equations. So let's maybe go to the first sentence. It says the total number of passengers during that morning shift is 1,000. So altogether, the total number of children, which is X, and all of the adults, which is Y, has to add up to 1,000. So this is all about number of people. If you want to think about units, the number of children, the number of people of children, the number of people of adults equals the grand number of people. People and people equals people. Great way to help figure out how to solve these problems is you get your units the way it is. Now everything else up there is all about a dollar amount. So let's think about it. The child's fare is 50 cents. So per child, it's 50 cents. And then for adult, it's $1.50. So for each child, per child, so 0.50x per child, plus per adult, so 1.50y equals, and we got to think about another dollar amount here. Well, it said total fares were $1,300. So this equation is all in terms of money again. That's a great way to split up the values. Okay. So now let's go back and use an elimination method. Let's say I just want to go with the x's again. So it looks like this top equation needs to be multiplied by negative 0.50, so that way we can eliminate the x's. So let's rewrite the first one now. It'll be negative 0.50x minus 0.50y is equal to a negative 500. And then the second one we're just going to leave as is. Okay, and because my x's are opposite in sign, I just get to add these two up as is. So the x's are going to go away right now because a negative 50 and a positive 50 wipes out. $1.50 minus 50 cents is just 1, so y is by itself, that's nice. And 1,300 minus 500 is 800. So it looks like we found a value. So the number of adults riding the bus is 800. And then the number of children, remember if we go back to that very first equation, it says the total number of people needs to be 1,000. Well, if 800 are adults, the only thing you can add to 800 and get 1,000 is 200. So just like that, and there's our answer. Not too bad for word problems, right? We're like, okay, we can stick with these word problems. Not too bad. All right, let's go to number 7, or example 7, which is number 25 in the book. Pause the video, kind of get an idea what you want the variables to be, and then let's hit play again. All right, well, reading through this problem just one time, it's roughly we're looking at trying to figure out how many cars we needed and how many of each type. And the last sentence, if you kind of look at that, what we want to do is determine how many cars of each type will be purchased. Okay, so if we let's just X be the number of compact cars, Y was intermediate, I just said mid-size, same thing, and Z then is the number of full-size cars. So we have 3 types of cars, therefore we have 3 variables. We had 2 types of crops like corn and wheat earlier. We had 2 types of riders, passengers, which were adults and children, but this time we now actually have 3 categories here. Compact, mid, and full. So therefore, now that I have 3 equations, or 3 variables, I'm looking for 3 equations specifically. So let's just read through the top, going down. It says that this Hartman Rent-A-Car has $1.5 million. All right, so we're talking about a dollar amount. Let's see if we can build an equation around a dollar amount. It says that, let's see, each of these small, middle, and full-size cars, compact cost $12,000, intermediate cost $18,000, and full-size cost $24,000. Okay, so it looks like we have a bunch of dollar amounts in here. We have compact cars, and they are worth, let's look like $12,000. So we have, let me write this out, $12,000 per compact car, so 12,000x. And each mid-size car, that one is 18,000. So 18,000 per mid-size, so Y, and then 24,000 for the large. Now the question here is right here. We have dollar amount, dollar amount, dollar amount. On this next dollar amount, which is a grand total of how much we can spend, we have 1.5 million. But I don't want to write just 1 equals 1.5 because everything here on the left is in terms of thousands. You can't have thousands equals to millions. It's not going to work that way. So what we got to do is instead of writing it as 1.5, we got to literally write it out as 1,500,000. So that way we have 12,000, 18,000, 24,000 doesn't equal millions. It equals, well, I mean, it's millions, but all the units are still in terms of thousands. Okay, big key there. All right, so let's go past that sentence. And it says, Hartman purchased twice as many compacts as intermediate cars. And the total number of cars to be purchased is 100. Well, let's do that total number of cars. That's pretty simple. The number of each type together, so X plus Y plus Z, has got to be 100. That's not too bad, because grand total. And now the part where it says, Hartman purchases twice as many compacts as intermediate sized cars. So another way to read that then basically is it's saying then the number of compacts has to be double the intermediate. So the number of compacts, X, has to be double the intermediate. So does that make sense when I read it like that? Because the number of compacts, which is X, has to be whatever the number of intermediates were, but then times 2. So it has to be double that, and that'll give us what X is. Okay, so all we have to do from here is just try to go through and let's say like eliminate some of the variables. We're just going to, when we have 3 equations like this, our goal is to kind of work with 2 at a time and just kind of pair them up. Okay, and how I'm going to handle the pairing is basically, it's kind of based all on what's happening here in this third equation. You see how this third equation I have right here is just in X's and Y's? So I want to kind of keep a bunch of just X's and Y's around. So let's go up here to the first 2 equations and let's see about eliminating those Z's. Let's get the Z's out of there so everything's just kind of in terms of X's and Y's. Alright, well in this top one I have 24,000 Z's. In the bottom one I just have 1. So if I want to eliminate my Z's, it looks like I need to multiply that second equation by a negative 24,000. So let's just compare the top 2. So if I write that as 12,000x plus 18,000y, 24,000z equals 1,500,000. And then we'll have then the negative 24,000x minus 24,000y minus 24,000z is equal to, we just add on, let's see, 2 more zeros, so that'll be a negative 2,400,000. So if we add 2 more, 1, 2, 3, 4, yep, there we go. You remember how that's pretty much the easiest way to multiply anything times 100 or 1,000. However many zeros are, you just tack those onto the end right there. That's an easy way to do it. Okay, so let's combine these together. If we have a negative 24,000 and a 12,000, that'd be a negative 12,000 x minus 6,000 y. My z's are going to go away. It's equal to, looks like a negative 900,000. Okay, so we've got this equation. Let me write that again, just kind of up over here. A negative 12,000x minus 6,000y, whoops, 1 more zero in there, is equal to a negative 900,000. Well, I'm kind of stuck with 2 variables here. I don't really have an x equals or a y equals, so what can we do? Well, this is the whole reason why I eliminated the z's, first of all, was because, again, going back to that third equation, I've got a tool. This third equation tells me I can replace all my x's with 2 y's. So I can replace that x right there with 2y. So that'll give me a negative 12,000 times 2y minus 6,000y is equal to a negative 900,000. And look, now all I have is 1 full equation in terms of y. So if we double this up, let me go ahead and I'm going to kind of just skip ahead just so we can save some space right here. Let's go and go 2 times the negative 12,000, so that's negative 24,000 minus 6,000. That's a negative 30,000y is equal to that negative 900,000. And then if we divide everything through by that negative 30,000, you get y, just to be simply 30. That's a good sign. We got a nice whole number. I kind of would be worried if it came out to be like, let's say even 30.5, because remember, y represents the total number of cars, and that's kind of good that if it comes out to be something like, 30, it works out. So I'm just going to put a 30 right here, so I don't have to really write all my full answer. So we at least know what y is. Well, because I know y, don't I know x? Coming back up here to that third equation right there. X has to be double of what y was, because the number of compact cars was double the intermediate size or the mid-size. So then the number of compact cars was 60. All right, well, one last thing then, just to call this finished. Total number of cars, look at that second equation right there. The total number of cars was 100. Well, 60 compact, 30 mid-size, all I have left then to add up is 10 to get a total of 100 cars. And there you go. There's the breakdown of exactly what you need of each type of car in order for this Hartman company to expend exactly $1,500,000 and to get exactly 100 cars.